In lesson 18, we have so far been doing in the previous lessons perfectly proportional. They're actually called direct proportional because when we start looking at inverse proportional, it's going to often have the, I consider it my perfect. They will sometimes refer to it as your direct proportional situation. And we've looked at that already, right? So inverse proportions, also called inverse variation situation, is when one variable increases as the other variable decreases. Now let's go back to a proportional situation. A proportional situation would be in a case where everything, both x and y, are increasing. That's therefore it always creates that upwards type of graph. So in this one, you would have 1, 2, 3 happening. You would have, for example, 5, 10, 15 happening in every single situation there. They're both increasing. And when I actually go and graph this, right, it creates that straight line that goes right through the 0, 0. That's a direct proportional, my perfect proportional situation that we've been doing. Now the difference between that and what we're doing now in this lesson is that we're calling this inverse proportion. And hint, that means, like the statement said here, that means inverse proportion, also inverse variation, is when one x increases as the other value y decreases. So for example, if I have numbers like 1, 4, and 10, those are increasing, while my other one might do this. I have 100, I have 25, and I have a 10. So you clearly see that one is increasing the numbers and the other one is decreasing. So totally different than what we did up here for a proportional situation. That's the first thing you look at to compare both. One is proportional and one is inverse proportion. So right there, that helps you. Also, you have to notice that I'm no longer able to say y divided by x here. You have to say, in this situation, you're going to see that you can't do y divided by x. Y divided by x works for this situation, right? So here I would say 15 divided by 3, 10 divided by 2. My proportional situation here would be, my proportional coefficient here would give me a perfect 5. Where this one, it does not work for an inverse proportion. You can't do that. But if you notice, my trick here is now called the product of x and y. That means this, x times y. If you look at this one, every single time, when you multiply the x and y, it gives you a 100 every single time when you're multiplying. Nothing to do with the zeros. So think, if I actually graph this situation, very roughly, okay, and on the next page we'll do it in more detail. But if I graph this situation, okay, and I plot my numbers roughly, my 1 and 100 would be way up here. My 4 and 25 would be way down here. And my 10 and 10 would be over here. So notice what kind of graph it creates, okay? So it's going to create that curve type of graph. And we're going to get into more detail in the next page. So these are a bunch of examples of what's happening, right? So if we're looking at proportion, both things would be increasing. For example, the more hours I work, the more money I make. In this situation, one has to go up while one is going down. So for this first one here, the time taken for a journey is inversely proportional to the speed of travel. That obviously means if I'm going super fast, so if I'm comparing two things, if I'm comparing, because speed of travel talks about how many kilometers you're going, right? And time. Comparing those two obviously makes how fast or slow you're going. So if I'm traveling 100 kilometers in 1 hour, but I'm then traveling, let's say, no, let's go back. I'm confusing you on that one, okay? Hold on 1 second. So let's put this in a table. Maybe that'll be a little bit easier for you guys to understand if I really clarify that and go X and Y. So for example, my time is here, and I'm going to travel 1 hour, 2 hours, 3 hours. Nope, let me start that over again. Sorry about that. See, I'm making it real, like just in the classroom. So for this here, the time taken for journey to inversely proportional speed, I'm trying to get my thoughts here through properly so I don't confuse you. So obviously, the faster you go, less time it takes to get somewhere, correct? Forget the numbers, too confusing. So the faster you go, so for example, if you're going 100 kilometers an hour compared to 120 kilometers an hour, right? If I'm comparing that, if the faster I go, the less time. So let's say for this trip, it would take me an hour to get somewhere. Well, here, if I'm going faster, it's going to maybe only take me 50 minutes to get there. So notice how this is increasing in speed. My time is decreasing. The next one, if I have one person, you know how bad I am at drawing. If I have one person shoveling, doing a job, yes, that's a shovel, and they're digging a big hole. The time needed to dig. So obviously this could take me hours and hours and hours to do that, right? So the more people you have, what happens? So if I have more people digging, right? More people, what happens to your time? So more, less time that it takes. Inverse proportion. Now comparing these two areas. Now my key here is that whenever I'm multiplying, this is a true situation where it's proportional. So if I have a certain budget and I can only use up 6 centimeters square here, let's say it's meters for it's an outdoor project. Well, I want to make sure that if I'm comparing two things, so for example, my X and Y in this case could be my length and my width because we're talking about rectangles. So if I'm talking about my length in the small one, let's say it's a 3, and my width is a 2, and I'm comparing it to the other one, this one, my length is a 6, and my width is a 1. So right away there, notice that this is increasing while this one is decreasing. Right there, it's inverse. And my other thing I can check to see if it's perfectly inverse proportion is that I multiply these two. So 6 times 1 is 6, 3 times 2 are both 6. They're going to give you an area of 6 no matter what. This you call your testing it. Remember, inverse, you have to multiply them. When it's the other one in the previous lesson, we would have to divide our y divided by 2 to get our proportionality coefficient. Now let's take all that information and put it in something from beginning to end. So the secondary 5 students are organizing the graduation dance. The fundraising activities during school have enabled the graduation dance committee to accumulate a surplus. That means they have extra money. This amount must be shared with every student who attends the dance. So they're going to get a refund because they're trying to make it fair. So obviously, over here, the more people that participate, obviously, the less money they're going to have. So right there, I see that this is increasing while this is decreasing. That is inverse. That has to happen. But to prove that it's perfectly inverse, I want to do the product of the X and Y here. So whenever you multiply, no matter which one you pick on, 200 times 12, 150 times 16, $120 times participants times $20. Every single time you multiply here, it's going to give you 2,400. And that's important because you don't want to make a mistake, because you want every student having a refund, because your magic number is you do have a surplus of $2,400 left over. So again, increasing and decreasing, and the product of the extreme. Can I take now all those numbers and graph them properly? So if I keep track, I might be jumping up and down. Maybe I'll just shrink this here. It would be a little bit easier. Okay, so obviously remember, guys, your key here, your Y and your X, please don't forget which one goes where. This is always your 0, 0 down here. And then you want to graph something, right? So if I'm looking at my X and my Y, that never changes, top of the page. And I want to graph that. So I want to see if I have 2, 4, 6, 8, 10, 12, 14. I have about 17 or 18 spaces here. Okay, this one here I probably have 4, 8, 12. I probably have about 20 on this side of space. So I want to make sure that I'm fitting my graph, my scale properly. Remember how I penalize you if you haven't labeled something. So therefore I need to go back, make sure that you're putting a label. So my X are the people, the participants, and my Y here is my money. I have to label that or you lose points. You lose points if your X and Y are reversed. You made a mistake. And it is definitely crucial if you don't have the 0, 0 happening. So I need to graph on the X 50 to 200. So if I just make this a little bit bigger, I have to graph from here to here, and I want it to fit 50 to 200. I cannot just plot those numbers only. I have to scale it. Now I'm going to be really tiny here on the bottom because I don't have a lot of space, but I need to make sure that if I have about 18, to me, I'm going to maybe put every 25 maybe. So 25, 50, 75, 100. If I do that, my 200 stops here. So maybe I can jump by 20 instead, or 10. 10 doesn't fit because I know I don't have 20 spaces, but maybe I can jump by 15. Okay, so if I actually do that properly, and I put 15, 30, 45, just be patient with me, 75, I don't make a mistake, 105, and I keep on going. See, 100, I'm about halfway through my graph, so that's a nice actual size. So I'd say 120, 135, 150, 165, 180, 195, and then here I have a 210. And if I want to just check my math a little bit to make sure I didn't make a mistake, does 210 go evenly if I jump by 15? Yeah, and I should have used 14 spaces. So I'm just checking a little bit there to make sure I haven't made a mistake by my scale of 15. Because if I do, then it just totally warps my other stuff. My Y. In my Y here, I have my smallest numbers at 12 and my biggest number, right? Minimum, maximum. So 12 to 48. So I have lots of space here. I can't jump by 2 because 48 divided by 2 would be 24 spaces, and I don't think I have 24 spaces here. So maybe I will jump by 3. If I know that I had 2, 4, 6, 8, 10, 12, 14, 16, I do have 18 spaces here. If I want to do it really easy and accurate, really trick, right? My max number is this divided by 18 spaces. I can literally point 2.6, but it's too small. So I'm going to jump to 3. I'm going to make sure that I'm just looking at jumping by 3. If I do that, then everything fits. So go ahead and put those numbers in. I'm going to just change colors so I can, a little bit of a difference here. So 0, 3, 6, 9, and then keep on going. Whoops, maybe not the 1800, right? 180. So 18, just make sure that you're doing your multiples of 3 properly. 30, 33, 36, 39, 42, 45, and 48 is my max that I need. So you can go one further if you want, but 48 is your max. Now go and plot it. Now, it's important that you're following this, right? So 50 is the X, 48. So if I have 50 would be, if I'm down here, right? So my 50 is between 45 and, so I'm about here for my 50, right? Sorry, yeah, 45, and this is 60. So I would put that into 3 sections. So that would be 45, 50, 55, 60. So right here. And then I want to line that up with the number, if I remember correctly, 50 and 48. So my x is 50, and I have to go all the way up here. I will erase that in a second, is right here. So 50 and 48. My next number, sorry, I'm jumping around here, 60 and 40. So 60 is a little bit easier. So I have my 60 down here, and my 40. My 40 would be about, so I'm got a line up here. I'm going to have, this is my, I can't keep track of the line here. And my 40 is about here. If I keep on graphing this, and so on and so on and so on, it does create that curve aspect to happen. Okay, so you want to make sure that you're plotting all those next dots. You notice 2 things happening. It never touches the x or y axes because there's never a 0, 0 happening. And that's because you can never have, for example, you can never have the product of x times y to be equal to a 0 because it doesn't exist in an inverse proportional situation.